Hello my dear students, welcome back to Pen and Paper Chemistry, and we continue with the topic of carbon and its compounds. In this video, we shall be understanding the different ways of representing an organic compound. So if you see over here, I have listed all the different ways and we will be taking them up one by one. What do you have to do? You just have to keep your pen and notebook handy so that you can take down the notes for offline reference. This may appear to be a very short topic, but it is very, very important because you need to understand what representation is being asked of you, or how do you have to represent the compound. In the example here, I am taking up ethane, C2H6, the different representations of ethane, having 2 carbon atoms and 6 hydrogen atoms. See the first structure over here. Here we have represented all the bonds that are there, all bonds which are there in the ethane molecule. So 2 carbon and 6 hydrogen atoms with all their bonds displayed. It is like an exhibition where each and everything is clearly shown, is on display. Hence this particular representation is known as a displayed formula. If you recall all these structures that I had drawn while explaining to you saturated and unsaturated compounds and unsaturated hydrocarbons, see, we have depicted the bonds wherever they are present. So if it's a triple bond, 3 dashes. If it's a double bond, then there will be 2 dashes here. Single bond, single dash. So all bonds are on display. Hence the name displayed formula. Now you see over here 3 hydrogen atoms on 1 carbon atom and 3 hydrogen atoms on 1 carbon atom. So it is like in an exhibition you have 3 copies of the same book. So instead of putting all 3 copies on display, what would rather be more convenient is to put the 3 copies of the same book together. So that is what we have done over here. CH3, CH3. That means you have brought them together. You have clubbed the bonds in such a way that I do get an idea about the structure, but I don't take as much space as in the above representation. Hence, this is what we call as a structural formula. It gives me an idea about the structure of the organic compound. Now let's go on to the third one. Oh, see, we have done away even with the single bond between the 2 carbon atoms. So we can either show it by a small dot over here, or we can just do away with that dot as well. So what we've done is we've condensed the formula or representation even more. So what we've got is, this is called as the condensed formula. Now I've tried to give you clues over here. The first one, this representation displays all the bonds and atoms, hence the name displayed formula. The second one, structural formula, gives us an idea about the structure with only some bonds shown. So for example, if I have a doubly bonded compound, I will show it like this. CH2 double bond CH2. If I have a triple bonded compound, I will show it as CH triple bond CH. So I am showing only some of the bonds, not all of the bonds, and that gives me an idea about the structure of that particular compound. Now, how do I put it as a condensed formula? The same thing, but here because there is the presence of a triple bond, we will show the bonds like this, CH triple bond CH. So what we've done is we've condensed the display to put together atoms attached to to carbon or another atom. Hence the name condensed formula. Oh, now look, there are 2 carbon atoms in the molecule and 6 hydrogen atoms. What is this? Yes, you have been doing it in your previous classes as well. This is nothing but molecular formula. A representation which is telling me how many carbon atoms are there and how many hydrogen atoms are there. Similarly, if I have to represent this compound, I have to write the molecular formula. I am simply going to write it as C2H2. If I have to represent this compound, I will simply write it as C2H4. Molecular formula, a representation or formula which just gives me the exact number of atoms of each type present in one molecule of the compound, hence the name molecular formula. Come to the next one. Here CH3. What have I done? Is this the formula? Look at the ratio of carbon to hydrogen over here. It is 1:3. 2 times 1, 2 times 3 is 6. So 1:3 is the ratio of carbon to hydrogen. This formula only gives me an idea about the whole number ratio of the atoms present in a compound. Hence the name empirical formula. Now, if I have a compound C2H2, what will be its empirical formula? Yes, CH. If I have a compound C2H4, what will be its empirical formula? 2 times 2 is 4. Yes, it will be CH2. Gives me just the ratio of the atoms of the different elements present in a molecule of the compound. Now, what about the empirical formula of a compound like CH3Cl? Think about it. What will be the ratio? So, presently you have 1 carbon to 3 hydrogen and 1 chlorine. Can we make it simpler? Yes, you cannot. Hence, the molecular formula and the empirical formula of this compound is the same. So let us define molecular formula. This representation just gives us the molecular formula. How many atoms of each type are present in one molecule of the compound. Empirical formula gives us the simplest whole number ratio between the different atoms in the compound. So you notice the difference, but yes, for some compounds, the empirical and molecular formula can be the same. Lastly, you see this line drawn over here. What does it depict? This line is indicating that there are 2 carbon atoms at the end, and the valencies of these carbon atoms are satisfied by the hydrogen atom, and these carbon atoms are joined by a single bond. This is what it shows. Meaning to say, while drawing this structure, we do away with the carbon compound, the carbon atoms and the hydrogen atoms, because we know that we are talking about an organic compound which is made up of carbon and hydrogen. So here the valencies of carbon are satisfied by hydrogen. The single line over here simply means the single bond between the carbon atoms. Let's say I have to represent this CH3Cl by this structure. There's no bond over here, so I cannot exactly use this diagram. Let me take another example. So let's suppose I have to represent C3H8 by this representation. You see, we've done away with the atoms showing of the atoms in this structure. We are only showing the bones which are making up the skeleton. We are only showing the bonds which are making up the skeleton of this molecule. So for example, as I said, C3H8. So there are 3 carbon atoms. Now if I have to show 1, 2, so that means there's a carbon here, there's a carbon here, there's a carbon here. But while drawing this particular structure, I don't want to show the carbon. So what we do is, we will draw this like here. This means that there is a carbon over here, there's a carbon at each of the vertex here, and a carbon here. And you have to satisfy the valencies of carbon. So this becomes a CH3, this becomes a CH3, and this becomes a CH2. This is what it means. But while drawing the last type of representation, what we call as the skeletal formula, we are only showing the bones of the skeleton, the bonds of this molecule. This is C3H8, a representation in skeletal form. Would you like to try yourself one of the molecules? So let's suppose I have C4H10. Would you like to try drawing the structure for C4H10, the skeletal formula for C4H10? Okay, let's try it together. So 1. When I've drawn one line, means I've already taken care of 2 carbon atoms. You see 1, 2. But we will not write the carbon. 3. And then a 4. That's it. Because this is a saturated compound. You see, it agrees with the formula, or this satisfies the formula CnH2n plus 2. You have 4 carbon atoms. 4 times 2 is 8, 8 plus 2 is 10. So this is a saturated compound. Okay, let me give you a question over here. Let's suppose I have to draw the structure for C4H8, skeletal formula for C4H8. Give it a try. Yes, there can be different representations. So I'll take the easiest one for you first. I have removed hydrogen atoms from this, let's say the 2 carbon atoms at the end. So that means it develops a double bond. So to represent a double bond, I am going to simply draw a double line over here. And that's it. This becomes C4H8. This can also be represented as 1, 2, 3 and 4. And I could have removed the hydrogen from these 2 carbon atoms as well, and we could have drawn it like this. Yes, there are 2 structures possible for C4H8. What are these structures called as? They are called as isomers. We will be talking about them in maybe the next video or the video after that. But for now, just store it in your memory or just rake it in an interesting way. Don't stress about it. It's okay. It's a new topic. You will take some time to imbibe this. Okay, here I am giving you a question to do and try on your own. Represent CH3, CH2, CH2, Cl in different forms. So first of all, tell me what kind of representation have I shown over here. Have I shown displayed formula, or have I shown structural formula? Have I shown the condensed formula, the molecular, empirical, or skeletal formula? Which one have I represented when I am writing it as CH3, CH2, CH2, Cl? Okay, think. Go to your notes, think about it. Have a look. Say the answer to yourself. Imagine that you are sitting in a tuition class with me. We are sitting in a class. Yes, it's the condensed formula that we have. So we answered the first part of your question already. CH3, CH2, CH2, Cl, condensed formula. Now go ahead and pause the video. You have to pause the video and try these representations yourself for this particular compound. Don't worry, don't stress about it if you don't get it, but I will say at least try. Even if you don't succeed, at least try. Then after pausing the video, restart it to see the answers. So if you see over here, I will first attempt the easiest part, molecular formula. I just have to give the number of carbon atoms which are there. So I have 1, 2, 3 carbon atoms, and I have 3, 4, 5, 6, 7 hydrogen atoms and Cl. That gives me my molecular formula. It's very easy, sorted out. Okay. Now let me go on to the next easier part, empirical formula. Empirical formula means I have to give the simplest whole number ratio. Now there is no whole number ratio. If I divide 7 by 3, I will get something like 2 point something, which will not be a whole number. So that helps me sort out the empirical formula bit. So I have over here C3H7Cl. That becomes the empirical formula as well. See, out of 6 parts, I've already done the 3 parts, right? We've already sorted out CH3, CH2, CH2Cl. So if you are seeing in terms of marks, I have already got 3 marks out of 6. Yes, that is the trick to handle the examination questions as well. First sort out or first answer the questions that you are confident about or what you can think. And then if you find some questions tricky, you can go back to those as the next level. This 3 marks out of 6 gives me the confidence that yes, I'm 50% on the way. Yes, I love that smile. Okay. Now display means I have to display all the bonds. I have to put it on display. So 1, 2, 3 and a Cl, and then there is hydrogen, then there is hydrogen and a hydrogen, then there is a hydrogen and a hydrogen. So now I get 4 marks out of 6. Very good. I am on the way to success. Okay, how many of you were able to do till this point on your own without seeing the answer? Let's be honest with each other. Okay, glad. Now structural, I just have to give a basic idea about the structure. So that means now I do CH3 and a single bond over here, a CH2 and a single bond and a CH2 and a Cl. Isn't it easy? So now we have got, how many marks have you scored so far? 5 out of 6. The last one, which sometimes can be painful, skeletal. Let's try that. Now I have how many carbon atoms to adjust? 3. That means, will it be one mountain or no? Yes, there will be just one mountain, because I have a carbon here, I have a carbon here and a carbon here. Since I am depicting only single bonds, that means it will be CH3, CH2, CH3 so far. Okay, I have not put Cl. So for the Cl, I am going to put a dash here and a Cl. Understand the difference. If I put a Cl over here, that means I have got 2 carbon atoms and the third one is a Cl. In which case my compound will be CH3, CH2, Cl. Whereas this compound that I have got, it's 1 carbon, 2 carbon, 3 carbon and the end is a chlorine. So CH3, CH2, CH2 and a Cl. Okay, how many of you scored full over here? If you got all correct, it's time to now move on to the next video, that is naming organic compounds. But if you feel that you need further practice, then try drawing the different representations of the following compounds that I am listing. Even otherwise, even if you've been able to get all correct, I would say there is no harm in doing some more practice. Try drawing the different forms of C4H10, C4H8, C4H9Br, C3H7OH, C2H5CHO. What are these? COH, this is OH, CHO, COCH3. If you've been following the channel, you will remember that we have already dealt with these, what we call as functional groups, in previous videos. If not, it's time to rewind, it's time to go back to what we have already covered. As I've mentioned in my previous videos also, it is useful if you go through the videos in the series that they have been presented in the playlist. It will help you to consolidate your knowledge. It will also help you to gain confidence in the topic. Now, once you have practiced these structures, I will also give you the answers to these in the next video. And we will also start with the formal system of naming organic compounds, that is IUPAC system of nomenclature. So do stay tuned, and please, if you like the content of this channel, I would request you to share this gift of knowledge with your friends, your classmates, your juniors, even your seniors. There's a lot of content on the channel for students of grade 10, 11, 12. In fact, there are students who are doing graduation and who have found the channel and the topics covered herein very, very helpful to consolidate or clear their basics. Thank you so much for watching, and thank you so much for recommending the channel. Happy learning to all of you.